All right. Now we're in chapter 12, and in chapter 12, we're looking at the limits of a function. All right, we're going to start out by looking at what is the definition of limits. Now, the limit of a function is the value the function approaches at a given value of x. The limit of a function is the value function approaches at a given value of x. All right, let's have a look at the function f of x is equal to 1 over x plus 1 over x plus 1. And let us see what happens the closer x gets to 3. So at the top here we have x, we have 1 over x, and we have the function f of x, which is 1 over x plus 3. And you see close, the first thing we started out with x being 2.9. When you add 1 to that, you get 3.9. Now, f of x, which is 1 over x plus 3, becomes 0.256410. Alright, so as we keep going down, you notice that we're getting closer and closer to 3 until we're at 9 point, and as you keep going down, you notice that the value of f of x is getting closer and closer to 0.25. As x gets closer to 3, you'll notice the value of f of x is getting closer and closer to 0.25. At the bottom where x is 2.99999, which is very, very close to what? 3, f of x is 0.250001, which is close to 0.25 or close to a quarter. So as x gets closer to 3, f of x gets closer to 0.25, which is a quarter. So therefore we can say that the limit of f of x as x approaches 3 is equal to a quarter. And we would write that the lim of f of x as x gets closer to 3 is equal to a quarter. So we would say that the limit of f of x as x approaches 3 is a quarter. And we would write lim fx, and on the bottom x, an arrow to 3, and this is equal to 1 quarter, which is the same as saying the limit of the function f of x as x approaches 3 is equal to a quarter. Limit of a function, limit of a function that the function never reaches, whole in a graph. All right, let's have a look at the function f of x. So looking at limit of a function that the function never reaches. There are some functions that have a limit, but the function itself never ever reaches that value. All right, let's have a look at this idea. And if you were to draw a graph of that function, for that value of x, the function will have a hole in the graph. And all of this we're going to explain. All right, let's look at the function f of x, which is equal to x squared plus 3x plus 2 over x plus 1. The first thing we can do is that we can factorize the top. So we're going to have x here and x here, because x times x is x squared. We're going to have 2 here and we have 1 here, because 1 times 2 is 2. All right. And this is over x plus 1. All right, so we could cancel x plus 1, could cancel x plus 1, and we would be left with just what? X plus what? 2. All right, so let us examine now. Let's examine f of x, which is x squared let us see what happens to f of x. Let us see what happens to f of x as x changes values. Let's see what happens to f of x as x changes values. All right. So here we have x, different values of x, and in the middle we have f of x. In the middle we have f of x. All right, and to the right we have x plus 2. And we already show from up here that that x plus 2 basically approximates f of x, because x plus 1 cancels x plus 1, and so f of x is the same as saying what x plus 2. All right, but let us see what happens as x approaches minus 1. All right, we can see when x is 4, um, we have what x is 4. We're going to replace x, anywhere we see x we're going to replace it with 4. We're going to have 4 squared plus that should be 4 squared plus 3 times 4 plus 2. 3 times 4 here should be plus 2. Plus 2 divided by 4 plus 1, um, we're going to get f of x is equal to 6. To the right, which is easier, when x is 4, we have x plus 2, 4 plus 2, which is equal to 6. So you can bear this in mind for later. If we're going to plot a graph of the function y is equal to f of x, if we're going to plot a graph of the function f of x, one value on the function, one coordinate of the function is going to be x is 4 and f of x or y is equal to 6. All right, so we can actually have a look at that later. Just like for here, when x is 3, f of x is equal to 5. When x is 2, f of x is equal to 4. When x is 1, f of x is equal to 3. And when x is what? 0, when x is 0, f of x is equal to 2. So we have 0, 2. All right. And we're looking, and essentially, here's what we're seeing. We're seeing that for every value of what? Every value of x so far that we have looked at, the function f of x, which is x squared plus 3x plus 2 over x plus 1, has the same value as x plus 2. All right, and we could see that from the top that when we factorize x squared plus 3x plus 2, we're going to get x plus 1 multiplied by x plus 2, and the x plus 1 in the numerator and the denominator can cancel, leaving you with only what? X plus 2. So essentially, for every value of x so far that we have looked at, the function f of x, which is x squared plus 3x plus 2, has the same, divided by x plus 1, has the same value as what? X plus 2. All right. Now let us see what happens when x reaches minus 1. When x is minus 1, we get what? For the top, we get 1 squared, which is 1, plus 3 times minus 1, which is minus 3, plus 1. So at the top, we're going to get 1 plus 2 is 3, minus 3, we get 0. And at the bottom, we have minus 1 plus 1, we also get 0. So when x is minus 1, f of x is equal to 0 over 0. When x is minus 1, x plus 2 is equal to minus 1 plus 2, which is equal to 1. When x is minus 2, f of x is equal to 0, and x plus 2 is also equal to 0. So what do we observe so far? So far, what we observe is that 1, that for all x except x is equal to minus 1, f of x, which is x squared plus 3x plus 2 divided by x plus 1, and f of x is equal to x plus 2 have the same value. So for all value except x plus 1, they have the same what value. We started with x from x is equal to what? 4, and we went down to when x is equal to what? Minus 2. And for every value of x except x is equal to minus 1, f of x, which is equal to x squared plus 3x plus 2 divided by x plus 1, and f of x is equal to x plus 2 have the same value. What else have we observed? We have observed that for x is equal to minus 1, f of x is equal to 0 over 0, which is what? Indeterminate or undefined, and f of x is equal to x plus 2 is equal to 1. All right, so let us look at what happens, because remember we started out by saying value of a limit of a function that the function never ever what reaches. All right, and we also talk about holding a graph. So let's look at what would happen if we were to draw a graph of f of x, which is equal to x squared plus 3x plus 2 divided by x plus 1. We already showed that x squared plus 3x plus 2, we had factorized that to get x plus 1 multiplied by x plus 2 divided by x plus 1. The x plus 1 in the numerator and the denominator cancel. Therefore, that is equal to now what? X plus what? 2. So x squared plus 3x plus 2 is the same as saying what? X is the same as saying y is equal to x plus 2. So therefore, to draw the graph, when drawing the graph of y is equal to x squared plus 3x plus 2 divided by x plus 1, we will draw the graph of y is equal to x plus 2 instead, with an unshaded circle at the point minus 1, at the point minus 1, 1. The unshaded circle at minus 1, 1 is said to be a hole in the graph, and it indicates that minus 1, 1 is not part of the graph. All right. So what are we saying here? If you remember earlier when we got all those values, I think we had what, 4 when we were looking at values of f of x from values of what started for values of x from what 4 to minus 2. We got when x is equal to what 4, f of x was equal to 6. When x is equal to 3, f of x was equal to 5. When x is equal to 2, we got f of x is equal to 4. When x is equal to 1, we got f of x is equal to 3. When x is equal to 0, we got f of x is equal to 2. All right. When x is equal to minus 1, we got no value. We got 0 over 0, and 0 over 0 is indeterminate. So when x is equal to minus 1, there's no value of y. So this point, minus 1, when x is minus 1, that is not a point on the graph. For when x is minus 1, f of x has no value. So this is the graph of y is equal to x squared plus 3x plus 2 over x plus 1. So the graph of y is equal to x squared plus 3x plus 2 over x plus 1 is the same as the graph of y is equal to what? X plus 2 with a hole in the graph at when x is equal to minus 1. Because when x is equal to minus 1, there is no value of what? Of y. All right.